So in this calculation, we're looking at the law of conservation of mass. When I'm teaching the students I teach, I often call this the first law of chemistry. It's the most basic law, if you like, in that the atoms that go into a chemical reaction must come out of the other side, and they're not going to be any different to the atoms that went in. So you can't make or destroy atoms in a chemical reaction. So in other words, the mass of the reactants must equal the mass of all the products. The mass of the products can't increase, it can't decrease, because the atoms aren't going to increase or decrease. So in this question here, we're told 61.75 grams of copper carbonate is heated. Now there's only one reactant, and it's a thermal decomposition. So we heat it up, it breaks down. It's going to break down to copper oxide, and we're told 39.75 grams of the solid remains, where the solid is the copper oxide. So we've got 39.75 grams of that remaining. So we start with 61.75, and we have 39.75 remaining. Calculate the mass of carbon dioxide produced. Now, when you see that, you probably immediately think a calculating quantities question, where you have to calculate moles and then do the stoichiometry and then the moles at the end. Now, you can do it that way, but there's no need in this case, because the law of the conservation of mass applies here. We know the mass of the reactant, we know the mass of one product, so the remainder, the difference between 61.75 and 39.75, has to be the mass of carbon dioxide. So it's a simple subtraction. Subtract that from that, and you get the mass of the carbon dioxide that's left. Okay, think about it. You know, if this was 20 grams here and that's 10 grams, how much must that be? Well, the answer is another 10. 10 plus 10 equals 20. So we're going to subtract the mass of the copper oxide from the mass of the copper carbonate. So straight away, it's just going to be 61.75 minus 39.75. Put that into a calculator, and we should have an answer pretty quickly. It's a very straightforward calculation. A lot of students don't see it as straightforward because they think it's a more complicated calculation. Now, in the exam, there's a very simple way to see whether it's a complicated calculation or a simple calculation. You just have to look at the number of marks available. Answer 22. 22 grams. Okay, the way you see if it's a simple calculation in the exam, I have a sample question here, is you look at how many marks are available. A 1 mark question says it's a simple calculation. So calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. We have our equation here. We're told we have 16 grams of calcium carbonate, 16 grams of calcium carbonate. Heated strongly for 10 minutes, that's just unnecessary information. 12.426 grams of solid remained. There's the solid. 12.426 grams of solid remains. So the difference between those two has to be the mass of the carbon dioxide. Calculate the mass of the carbon dioxide gas produced. It's a 1 mark question. You can do moles, stoichiometry, moles, but that would be a 3 mark question because there's 3 stages there. Here it's just a simple subtraction. So 16 minus 12.426. Into our calculator quickly. 16 minus 12.426 equals 3.574 grams. Equals 3.574 grams. 3.574 grams. First rule of chemistry. All the atoms here, all the calciums, all the carbons and the oxygens, every single one of them must be on the product side. So if we know the mass of one product, we can simply subtract that away from that one and get the mass of the other. It only works if you only have one unknown. It's worth thinking about that, isn't it?